All right, so now that we've used our calculators, we're actually going to find out how to do this with algebra and then with calculus. So the first thing we're going to do is talk about the area under a curve that we know how to figure out. Like right now we don't know how to figure out how to do it under a curvy curve yet, but there might be other ones that we can find with algebra. So we're going to look at this first one. We're going to find the signed area underneath this curve. So again, an integral is really just what's the area under any curve. So we're going to start by graphing this curve, the absolute value of 2x minus 1. And so I'm going to draw it down here because I didn't leave myself enough room up there. So let's see, 1, 2, 3, 5, 1. Okay, so the vertex of this one is at negative, oh my gosh, I'm saying negative, it's at 1/2, 0, because when the function is equal to 0 at 1/2. And then when x equals 0, y equals 1. And when x equals 3, y equals 5. So I have this function here. And I'm trying to find the area underneath it. So that would be like this area right here and this area right there in each of those triangles, right? I'm just trying to find this area. And the cool thing is we actually know how to find the area of a triangle. So this is a lot easier than stuff we're going to do with calculus here in a minute. So let's figure out what that area is. Well, first let's figure out what the base of this triangle. That triangle has a base of 5/2, which is 2.5. Because from 1/2 to 3 is 2.5. Has a height of 5. This triangle has a base of 1/2 and a height of 1. So let's figure out what the areas of these triangles are. So the first triangle, we have 1/2 times the base times the height. And then we're going to add the area of the second triangle, 1/2 times the base times the height. So we have 1/4 plus 25/4, which is 26/4, which is 13/2. So the area under the curve from 0 to 3 is 13/2. Now the issue is that oftentimes, and really always, we don't always have like really nice flat surfaces like that. We don't have something that turns into a square or a rectangle or a triangle that we can find the area of really easily. We have things like this one that you see in front of you. This one is a little bit more complicated because there's a curve and I don't actually know how to find the area. Well, I don't until in a minute you'll know. But I didn't really know how to find that area under something like that because it's like this really, you can't really make it into a triangle or a rectangle or anything and have it be perfect. So we're just going to set up the definite integral that could be used to find the area. And so it looks like we're looking for an area between 0 and 2 because that's the shaded area, or we want x values from 0 to 2. And then our function is 2x cubed minus 3x plus 2, and then we write dx. And that would give us, I should put parentheses around that. The whole thing is being evaluated. So that's it. That's the integral that we would solve if we wanted to find the area under the curve. It doesn't actually ask us to. It just asks us to set it up. So let's take a look at some more stuff. So here's the fundamental theorem of calculus. All right. It sounds so exciting. It is. All right. The fundamental theorem of calculus. So let's take a look at this graph. We want to find the area under this graph. This is a derivative graph. So what is the area under this graph from 0 to 5? Well, from 0 to 5, it's this shaded region right here, and that just happens to be a rectangle with base 5 and height 3. So the area under that rectangle is 5 times 3, which is 15. So we want to write an equation for f prime on 0 to 5. So basically, what is the value of f prime. You know, this function, what does it actually equal? What's its output? Well, you notice that its output is, no matter what x I put in, its y value is 3. So my equation would be f prime of x equals 3. And now we're going to find f of x if f of 1 equals 4. So first thing we need to do is we need to find f of x, right? So this is our function. Our function equals 3. So we need the integral of 3 dx, and that would equal 3x plus c, because if we took the derivative of 3x plus c, we'd get 3. Okay, so that's our function. Now it says f of 1 equals 4, so then we can find that to find our c. So when x equals 1, y equals 4, so we have 4 equals 3 plus c, so c equals 1. So our actual function, f of x, is 3x plus 1. So that's our function. Now what we want to do is we want to find our function, the value of our function from 5 minus the value of our function at 0. So the value of our function at 5 would be, well, we plug 5 into that and we get 16. And the value of our function at 0 is 1, so that would be 15. Look at that. Weird. It's supposed to come out that way. So the value of our function at 5 minus the value of our function at 0 gives us the area under the curve. So let's take a look. Let's rephrase that. It gives us the area under the curve of that function's derivative. So that's where the integral part comes in. All right, so this one we're going to find the area under the curve from -2 to 1. So from -2 to 1, so that's these triangles here. So that would be, let's start with the one, there's 2 different triangles here. Yeah. So there's 2 triangles here, and I keep drawing them wrong. Okay, so really, if you think about the area under the curve means the area from the curve down to the x-axis. So that's this triangle here, right? That's this part. And then what from over down here, we're talking about this part in between the x-axis and the curve. Okay, does that make sense? So it's kind of odd to think about that being the area under the curve, but since this curve is below the x-axis, it's basically from there up. So the area of that triangle would be -1/2 times 1 times 2. And the area of the other triangle would be 1/2 times 2 times 4. So in the end, we add it all together, and that gives us 3. So that's the actual area under the curve, because if you think about it, this area underneath is kind of like negative area. It kind of takes away from the area up above. So we're going to write an equation for f prime of x on -2 and 1. Well, it's a line. It looks like it's a line with an intercept at -2 and a slope of 2. Sorry, an intercept of +2. So that's there it goes. Okay, there's my equation for that's the actual equation of the graph that we see. It's just a line with 2x plus 2. And then our equation for the actual actual function, so again, we would integrate this because we're going backwards. That equals 2x squared over 2 plus 2x plus c. And so that's x squared plus 2x plus c. And we know that f of 1 equals 0. So when that equals 1, that equals 0. So we have 0 equals 2 plus c. So c equals negative 2. So our actual function is, oh my gosh, that is not 2, that's 3. That's 3, because it's 1, 2, so that's 3. So our c is negative 3. So our equation for our actual function is f of x equals x squared plus 2x minus 3. So that's our function. And then if we want to find the value of this function at 1 minus the value at negative 2, I bet you can guess what it's going to be. So the value of this function at 1 is, let me not do this wrong this time, 1 plus 2, which is 3, minus 3, which is 0. And then minus negative 2, so it's 4 minus 4 minus 3. 0 minus negative 3, which gives us a positive 3. And so the area under the curve was 3. Area under the curve was 3. And the value of its function at 1 minus the value of the function at negative 2 is 3 as well. You might be seeing a pattern here. So, what does that actually mean? The fundamental theorem of calculus, oh, just kidding, I missed one. One more. That's the position equation for an object moving on the x-axis. So the displacement of the object at the interval, all right, so remember displacement is going to be, we're going to look at what is the, the value at 4 minus the value at 1. So the displacement is going to be the value of that at 4, which is negative 1/2. I was going to try to do it all in my head, but I know I'm going to get it wrong. So that's negative 8 plus 16 is positive 8 minus 3 is 5. And then minus, I have a cheat sheet to make sure that I do all the math right in my head because I'm not great at it, like when I'm watching the clock and everything. Okay, so 1/2, 4 minus 1/2 is 3.5, minus 3 is going to be negative, it's going to be positive 1/2. Yep, positive 1/2. So displacement is ending value minus initial value. So 5 minus 1/2, which is 4.5. I hate to write mixed numbers, but it just makes sense right now. So 9/2. Okay, so that's 9/2. So find the velocity equation. Well, the velocity would be the derivative. So we have negative t plus 4. And then sketch the graph of that. So that would be a line that has an intercept of 4 and a slope of negative 1, which would mean that right there. And then find the value under the curve for that. Well, that would be just the area of this triangle right here. And what's the area of the triangle? What's the 4 by 4 triangle? So we have 1/2. Oh, but it's from 1 to 4, not 0 to 4. So it's actually a 3 by 4 triangle. So it's 1/2 times 3 times 4, which is 12 over 2. Just kidding. Oh yeah, the value at, oh my gosh, it's a 3 by 3. It's a 3 by 3. 3 by 3, so it is 9/2. And you see that the value of the integral is also equal to the value of